Hello, it's Aldnar Nivek here, talking about A-level Maths, AQA and OCR Spec Core 1. There's a section on the equation of a circle and properties of a circle. So we'll look at how the equation of a circle is derived first of all. I think most of you could quote the equation of a circle, but how we get it. If we look at the simplest case on the left here, where we've got a circle with a centre at the origin, so the centre is at the origin there, and this is the radius, so we'll call that R, we'll call the radius R, and this is at the point xy, so the point there is xy, this being x and that being y. So I think we can see quite easily that x squared plus y squared equals r squared by Pythagoras. So applying Pythagoras to that, we can see that x squared plus y squared equals r squared. And that gives us the equation of a circle, centre the origin, where r is the radius. Now if we move the centre from the origin to a point along the x-axis, and we'll call this distance A. So the centre of this circle is now x is the centre of this circle is now x. The centre of this circle is now point A on the x-axis, and y equals 0. So again, applying Pythagoras, if this is x, then this distance here is x minus A, and this distance is again y, and that is r, the radius. So for this circle we have x minus A squared, x minus A squared, that's that distance there, plus y squared equals radius squared equals r squared. Looking at this one, here we've got the centre of the circle is at a point there, so it's not at x equals 0 or at y equals 0. Again, we'll put that distance as A, and we'll say that its length up the y-axis is B, and again this is R. So this distance here, that is x, this distance here is again, that distance is again x minus A all squared, plus this distance here is y minus B all squared, because this is B, so it's y minus B, and if we square that, that equals r squared, radius being r. So we rearrange that equation slightly, and we've got x minus A squared all squared plus y minus B all squared minus r squared equals 0. And that will be the equation for a circle. If we multiply this bracket out, you'll find we get x squared minus 2ax plus a squared, multiplying these brackets out, plus y squared minus 2by plus b squared minus the r squared there equals 0. Collecting terms, we've got x squared plus y squared minus 2ax minus 2by plus a squared plus b squared minus r squared equals 0. And either of these forms, this one or this one, is acceptable for the equation of the circle. So now we know how we get that, how it relates to the circle in question. We'll be looking at the next lesson on how we actually use this equation within the specification. Next we're going to look at properties of the circle. Now there are 3 properties of a circle that are mentioned in the specification. And these are the 3 properties. The first one says that the angle between the diameter and the tangent at the point of contact is a right angle. So it says that if you draw a tangent to a circle, where that tangent meets the diameter, then this angle is 90 degrees. The second one, if we move the tangent in slightly, so it actually cuts the circle at 2 points and becomes a chord, you say where the diameter cuts a chord, the chord is bisected, that means it's cut in half, that equals that at right angles. So it's the diameter is the perpendicular bisection of the chord. The third one says that any angle in a semicircle, that's an angle subtended by the semicircle, is 90 degrees. So we've got one there, we've got another one here, we've got another one there. So those 3 angles are 90 degrees. And next lesson we'll look at how we use these properties and the equation within the examples and the specification. So thanks for watching. And we hope to see you next time for the next lesson.